Okay, so now let's take a look at these graphs. Well, I'm not going to draw them because I have the screenshots of these graphs. Okay, I think that would serve a better purpose for me to teach you instead of being distracted by my poor drawing capability. Okay. Now, if you look at the first three graphs, okay, the top three graphs, you can find something consistent. What's the something that's consistent for top three graphs? Yeah, at least one of the petals. And let me go ahead and use green to highlight the petal that's on the axis. And they are very consistent. They're all on the positive x-axis. And speaking of petals, now again, officially they are named, the names of these shapes are called roses, which I would say mildly disagree because I don't see how they are like roses. But whatever, they're called roses and they have petals. And then we say, well, how do you figure out the number of petals? How do you know the number of petals for these graphs? The number inside a function to trig function, or in a more direct way to describe it is the number that's in front of the theta. Okay, in front of theta. That's what's happening. Okay, so if you see this number is 3, then you have 3 petals. This is 5, you have 5 petals. This is 7, you got 7 petals. Okay, so that's very easy to tell. What about the number that's in front of the trig function? What does the 2 represent here? How long? Okay, the length of the petal, how long it would be. Like for this one, you can see that there's a point right here, that's 2. So you can tell that all value is maximum 2. And just a review from yesterday, remember what I said yesterday? That sine theta and cosine theta, they will fluctuate between which 2 values? 1 and -1, okay? Remember the graph that you drew back then? The waves, okay? The amplitude, 1, okay? It's gonna fluctuate between 1 and -1. So that's how we know that, okay, so you have a maximum R value of 2, and that explains it, okay? And then for the bottom 3 graphs, okay, the sine functions, what's consistent among these 3 graphs at the bottom? One of the petals would be on the y-axis, right? So now, so one of the petals would be on the y-axis. And now it brings us to a very intriguing question, and that is, how do we know if the petal is going to be on the positive y or negative y-axis? Because if you look at cosine, it's very consistent. It's always going to be on the positive x-axis. But for the sine function, like this one is on the negative y-axis. This is positive. This is negative. So how are we going to tell? How can we tell where it is going to, where it will locate, where it will be located? Okay. Louder? Okay. Well, if the number in front of the sign, well, that just tells you how long it is. I think it's just a coincidence that this is odd, this is even, and then, like, for example, let me go ahead and make a graph real quick. So let's just say we have, let me go ahead and delete this, and then we have graph entry, polar. So if you have an even, sine, 5, theta, well, that is on the positive y-axis. And then you switch to odd number, that just influences how long it is. It does not tell you whether it's on the positive or the negative. y-axis. So any other way you can tell the orientation or which petal or which part of the y-axis would it cover? Huh? That's no negative here. So in order to find out, in order to figure out what's going on here, we have to ask a question. And I want you to write down this question. The question is, where is the tip of each petal? Now, I want you to make use of this so that when you make your graphs on the front page, it'll be a lot easier. So let me bring back some terrible experience that you may have. Well, I don't know, a wonderful experience, if I may say it. Do you remember this? That we solve some trig equations and we say, hey, remember we say sine of 3 theta is equal to 1. Then we say, find out what theta is. Anyone still remember how to do it? Louder? Well, we say, well, 3 theta would be pi over 2, right? And why is there and? Because the domain, it's between 0 to 2 pi. And now we're dealing with 3 theta. So that means our domain will be adjusted to 0 to 6 pi. So we need to go 3 rounds, 3 revolutions. So pi over 2 will be the value of the first revolution. And then the second one will be 5 pi over 2. And the third one will be 9 pi over 2. Well, that's what 3 theta is. And then we say, well, what about theta? That will be pi over 6, 5 pi over 6. And then, well, 9 and 3, they would reduce each other. So 3 pi over 2. So where are these 3 points? Well, sine 3 theta is equal to 1. That means times 2. You have all values of 2 at these angles. So let me color code them one by one. So first one is pi over 6 right here. Okay. And then we have 5 pi over 6 right here. And the last one, let's use green. No, I've used green already. Let's do orange then. 3 pi over 2 right here. So that's how you know that the petal, it's not on the positive y-axis, but on the negative y-axis. And if you know this skill, then when you construct your table, which is on the first page, they ask you to make a table, right? And you have to list some theta values. Well, guess what you can do? You can just say, well, pi over 6, 5 pi over 6, and 3 pi over 2. What's the R value? 2, 2, 2. Nice and easy. Okay, you don't have to worry about, let me substitute in the theta, and you get all these random values. Well, this will be very consistent. Using your old skills. Hope you still have them. All right, now let's see how this question can be applied to the next graph. So we say, well, what about 3 sine 5 theta? Well, same question. Okay, where is the tip of each petal? So we say, well, sine 5 theta, it's equal to 1. Okay, sine 3 theta is sine 5 theta is equal to 1. And that means 5 theta is equal to pi over 2 and 5 pi over 2 and 9 pi over 2 and 13 pi over 2 and 17 pi over 2. Because it's 5 theta, it goes around 5 times. Okay? So far, so good? Well, what's theta? It will be pi over 10 pi over 2 because they cancel each other. 9 pi over 10, 13 pi over 10, and 17 pi over 10. And now, how do we know that it's on the positive y-axis? Right here. So, gives you a really easy way to tell where it is going to be located. And now, if you want to say, can I be smarter and lazier? I would say yes. Now, if you look at these two examples, what you find out is that when you divide the coefficients over, like on the left one, if you divide the 3 over or you divide the 5 over, what's going to happen is that the one that would tell you where it's located is the one that can be reduced. And that tells you where it's located. And you would expect that it's either pi over 2 or 3 pi over 2. So it has to be the one that can be reduced. So divide by 3, 9 pi over 3, it's pi over 3 pi over 2. 5 pi over 2, divide by 5, you get pi over 2. So that's how you can tell easily. So let's just pretend that we don't know about the shape of this graph. And we say, well, where will the petal align? Is it the positive y-axis or negative y-axis? So we ask the same question and we say sine of 7 theta, sine of 7 theta is equal to 1. So 7 theta is equal to pi over 2. So you continue to list them until when? Until you see a multiple of 7. That appears. And right here. So now, for the sake of completion or the integrity of the problem, we'll continue to list them. But you know which one is going to give you the sign, the indication. You'll be like, yeah, that's the one. That's the one, because when you divide by 7, this will become 3 pi over 2. And you know that the tip is going to be right here at 3 pi over 2. Okay, so that's a little question, okay, that we need to ask. So again, for cosine, it's very consistent. You see the petal laying on the x-axis, positive x-axis. But for sine, it gets a little bit tricky, and we can find out using this skill that we learned way back then, okay, a couple months ago.